physics time. Yay. Introduction. Tennis ball player. Upwards. 3.7 meters per second. What's the velocity? So V1 equals 3.7. V naught. We're trying to find V at t equals 0.4 seconds. So we have acceleration is equal to 9.8. So we use the first one. So we can have V, which is in your answer, is going to be equal to 3.7 plus 0.4 times negative 9.8. So we pull out the calculator. We get negative 9.8 times 0.4, negative 3.2. So that's 0.22. Negative 0.22. Which of the following motions accurately depicts the object's motion? Assume standard SI units apply. So the position is x, function of time, the motion. So the acceleration is positive, so it's not true. The average velocity over what time interval? You can't say average because you can have a start and a finish. So that's wrong. The object speed is decreasing. I agree with that. The initial position is negative 18. Initial position is negative 18. I disagree with that. The object speed is decreasing. The coach wants to determine the average acceleration of an athlete during the first 20 meters of a sprint. She places markings every 2 meters from the starting line to the 20-meter mark. Okay. So we have on the acceleration. So we have 20 meters. 20 m. She places markings every 2 meters. And something like that. She did it quickly. The 20-meter mark. Start line to the 20-meter mark. 20 meters. The coach starts a stopwatch when she starts running. We have time and X. Okay, so if we look at our reference, we have velocity, and so we know that our initial velocity v of 0 equals 0 if she's at rest. Acceleration is equal to our question mark, time is t, and velocity is time over delta x. Let me know our delta x. Position. If it's position squared, v of t squared as a t squared. So v of t as does be changing at point P. It is so at this point right here, it's upwards velocity. Right here, you're gonna have high. I guess it'd be decreasing. 3 meters up the right, 4 meters up. That's 3, 4, 5 triangle. I think that's it. It's either 30 or 50. If we look at that, that'd be 3, 4. I think that'd be the 50. The cannonballs fired from the left, and now we're at the cliff. T equals 0, we can ignore your resistance. Acceleration, horizontal acceleration. If we ignore your resistance, it should be 0. Because you have that v is equal to constant, and the derivative of constant is equal to 0. So it should be 0. Because you have nothing moving. It's horizontal. What's the skater's initial velocity? Okay, 3 significant figures. So staircase has a length. So we'll just draw this out. He has delta x equals 12. Vertical drop of 2. Delta y equals negative 2. Try to find v of 0. Acceleration is 9.8. Okay, so we have delta y. We need one more variable. We have acceleration. We don't have the final velocity. position of x, fifth position of x, that is we'll call that 2. And final x is 0. 2 plus initial velocity Vx 0t, so I think that's my initial velocity times time. All these have time in them. I'll do this later.